Hello class and welcome back to Algebra 1B Bootcamp. Now we are discussing writing equations of lines. We've graphed lines, now we have to write our own equations. We can write equations given to us from graphs, from points, or from applications. So first, let's talk about our steps. Whenever we are writing the equation of a line, we want to first find the slope. The slope could be given to us, or we might have to use the equation y2 minus y1 over x2 minus x1. And you may have seen this equation before, or at least I hope so. Then you will find your b. There are many different ways to find your b. If you have a graph, you could read it off the graph. If you have a real-world application, you might be given like your starting point, or you might have to find it algebraically using the y equals mx plus b formula. So let's dive right in. The easiest way is if I just give you the plain information you need. So if I tell you the slope is 3 over 5, that's your m. If I tell you the y-intercept is -5, that's your b. So you would say y equals 3 over 5 x plus -5, or you could just say that is y equals 3 over 5x minus 5. Typically, this is how you'll see it written on your EOC. Now, it could get more complicated, like if I only have 2 points. I could try to draw this, but I don't always necessarily trust my drawing skills, and it is quite possible that my y-intercept isn't going to be like a whole nice pretty round number, and I want to find my exact value. So first, finding my slope. You can use your calculator as much as you want, but you do have to be aware of the fact that when you plug things into this formula, you really have to simplify the top and the bottom of the fractions first before you try to do any kind of division. So first plug in your numbers. I have y2, which I have labeled 7, minus y1, which is 3. Your y's always go on top. And then you have your 4 minus your 2. It is very important that you stay consistent. So if you start with the second point on the top, you have to start with the second point on the bottom. Now do some math. 7 minus 3 is 4. 4 minus 2 is 2. Simplify that if you can. 4 divided by 2 is 2. That's my m. Now I have to find my b. To find my b, I'm going to use the equation y equals mx plus b. And I'm going to plug in what I know. Right now, I know that my m is 2. But I don't know my b. I can use one of these points to help me find my b. It doesn't matter which one. Typically, I pick the one that has less negatives and has smaller numbers because I'm less likely to make mistakes with those. Remember, 2 represents an x and 3 represents a y. So I'm going to plug in 3 for y, 2 for my slope, and then 2 for my x value of my point. Two times 2 is 4. I will subtract 4 from both sides. So 3 minus 4 is -1. And now I have all the info to write my equation of my line. Y equals 2, x minus 1. I could also be given kind of a word problem. So in 2000, there were only 25 rare sea otters left in the wild. In 2005, there were a remarkable 60 sea otters in the wild. Write an equation for the number of sea otters in the wild. Now, in a situation like this, typically you're going to think of 25 as your y-intercept, because that's where you're starting. We don't really want to assume that for our sea otters before the year 2000, we don't know what was happening then. So the year 2000 is technically our year 0. And then in 2005, or 5 years later, there were 60 sea otters in the wild. So we still have to find our slope. But we have kind of 2 points. The first point is the point 0, 25, our y-intercept. The second point, in 2005, so 5 years after 2000, I had 60. There's my 2 points. And then I can do my y2 minus y1. y2, y1, x2, x1. So 60 minus 25 over 5 minus 0. Let's see. 60 minus 25 is 35. And then 5 minus 0 is 5. So my slope is 7. And I know my y-intercept to be 25, so y equals 7x plus 25. From this, I could ask you to predict. I could say, how many sea otters will there be in 2010? And you would plug in 10 and see what you get. Topic number 2 would be systems of linear equations. Now, this gets a little tricky because you can either write things as y equals mx plus b, or depending on your situation, you might want to write them in what we call standard form, which is ax plus by equals c. And that is a very good equation if you have like totals, like big giant totals. This is good if you have like rates, or you can easily find your slopes. But either one can kind of be used interchangeably. Oftentimes these are substitution or elimination problems, but you can do them a lot of ways. So let's see what we have. Tickets for admission to a high school football game cost $3 for students and $5 for adults. During one game, $2,995 was collected from the sale of 729 tickets. How many students attended the game? In this situation, I don't really have a slope. Things aren't changing here. So writing something as y equals mx plus b is not going to be helpful. So looking at what I've got students and adults. If I'm dealing with students and adults, I'm going to call those my variables. So first off, the number of students and the number of adults attending the game total would have to equal the 729. Now, this 2,995 is another total. That came from the prices. Student tickets cost $3. Adult tickets cost $5. So what I'm going to do is say 3 times the number of student tickets plus 5 times the number of adult tickets has to equal 2,995. Sometimes this is half the battle, writing the two equations. And a lot of times on your EOC, that might be all the information they want. Just write the equations that could represent your situation. But sometimes you might have to actually physically solve. There's an algebraic way to do it, and there's a guessing and checking way to do it. It really depends on which way you're most comfortable. I'll show you both. You might want to try to do substitution or elimination. Since I want to know how many students attended the game, I'll take this, the 729 equals s plus a, and rearrange it. And I'll say a has to equal 729 minus s. And then I'll take this whole chunk and plug it in for the number of adults. I'll come over here. 3s plus 5 times 729 minus s, that's an s, not a 5, equals 2,995. You'll probably want to use your calculator for a little bit on this one, because 5 times 729, you have to distribute, is 3,645 minus 5 times s. Again, be careful when you use s's for variables because sometimes they look like 5s. Now I want to combine my like terms. I have 3s and 5s, negative 5s, which make negative 2s plus 3,645 equals 2,995. I'll move the 3,645 to the other side by subtracting it. And I get negative 650. So the number of students, 650, negative 650 divided by negative 2 is 325 students, which is a lot. Now that is certainly a lot to guess and check. But at the same time, if you use logic, if you were to just maybe make a table, okay? You have students, you have adults, and you have the cost. If you were guessing and checking, you would use these two equations to try to get yourself as close as you possibly could so that you could answer the question. So like if you guess 10 students, and then if you have 10 students, that means you would have had 729 minus 10 students. So that means you would have had 719 to give you 729 total, which is way crazy for a high school football game. But you can punch in your calculator to check. 3 times 10 plus 5 times 719 is $36,200 or $33,625, which is not $2,995. So that tells me that these two numbers are probably way too apart. So maybe I up it to 100. If this is 100, then this would have to be 629. And you could keep guessing and checking until you ended up in a situation like that, where you got to 2,995. It's probably not the fastest way, but if you're not comfortable with substitution and elimination, that's really your only option. So feel free to rewind and copy down any notes and let me check you.